Hi and Assalamualaikum. We are from Group 2F. We want to present Student Hostel Booking System, this is our title of group project. Before we continue to other slide, we want to introduce our team members.
Hi, I am Adriana Nasuha.
Hello, my name is Laila Zafira.
Hi, I am Nur Afika Fikriya.
And hi, I am Nurul Isma.
For our introduction, Student Hostel Booking System is designed to manage hostel room allocations according to preferences and requirements. It allows students to make their own decision based on their specific needs and categories. For example, who they want to be roommates with and which room they want to choose. It also enables staff to track student details, room occupancy status, and payment records. This system can be used by students and hostel administrators.
Moving on to the next, which is objective of this project. We have outlined 3 main goals. The first one is to plan a system that helps college management handle rooms easily and effectively to avoid double booking problems. Second, to design a user interface that allows students to sort between rooms and easily to choose between solo or group booking rooms. And the third, to implement a capacity checking features that monitor the maximum space of each room to prevent any over allocation issues. The next one is the scope of this project, which covers our target user and system functionalities. For the target user, this system focuses on 2 groups. For college management, it is for the staff member. They are responsible for tracking room availability and managing overall room assignment. The second one, student. The university student who use the system to check their college application and also to book a room application. As for the system functionalities, it includes 3 main features. First, data input, where the system stores student personal information, room selection, and the type of booking, whether it is individual or by group. The second one is room management. The system automatically updates room availability once a booking is confirmed to strictly prevent any double booking issues. Lastly, information retrieval, which allows users to know the real-time availability of room and display a summary record of their successful hotel application.
Now, we will continue with the diagram. So now, I will be taking over from here to explain the cost structure of our system. If you look at the left side, this is our UMI class diagram, which basically shows how our code is structured behind the scene. At the top, we have our base class called user, which holds a basic info like user ID and name. You can see an arrow pointing down from it. That's an inheritance relationship. It just means that both student and system staff inherit those exact same attributes automatically, so we don't have to rewrite the code. Now, for the main operational classes, here is how they connect. Between student and booking, we have an association relationship with a multiplicity of 1 to 0 or many. This means one student can make 0 or multiple bookings. Between booking and room, it's 0 or many to 1. This tells us a single room can handle multiple booking requests, but each booking is tied to only one specific room. Lastly, the link between booking and receipt is a 1-to-1 association because obviously one booking application will only generate exactly one receipt. Now, let's move over to the right side of the image to look at the use case diagram. This is basically the flow of how a student interacts with our system. As the main actor, the student is connected to these actions through an association relationship. From here, they can check room availability, choose whether they want to book a solo or group room, and confirm their reservation. But there's a catch. If you notice the link between verify application status and log into system, there's an include relationship there. This means the system strictly forces the student to log in first. They can't just bypass security and check their application status without being authenticated.
This slide shows the input file for our room booking system. First, the student enters their name and student ID. Then, they select their room choice. If the first choice is not available, they can enter a second option. Next, they fill in the room number, booking type, the total number of students in the room, and the number of electrical items they will bring. All of this information is used by the system to process the room booking accurately.
Now, I will explain the coding of our system, which implement the concept of inheritance. First, we have the superclass called user. This class stores the core attribute shared by everyone, such as user ID and name, along with the basic method like login and logout. Second, we have the subclass student, which extend the user class. On top of the basic user info, it includes specific features for handling application such as add booking and checking approval via verify status. And third, we have the subclass system staff, which also extend user. This class is built for management roles, containing specific method to monitor and update room availability through track room state and update room status.
Now, I will continue with the booking class. This class is responsible for managing student inputs and enforcing our system main restrictions. To ensure data security, we use private attributes. Aside from basic info like booking ID and booking type, we also establish relationships, the room and receipt classes. This means every single booking is directly linked to a specific room and its generated receipt. Next, let's look at our business logic method. First, check capacity method. This method handles our room capacity rule. It compares the total students entered by the user against the room's maximum capacity. If it exceeds the limit, it returns false to prevent overcrowding. Second, check electric limit method. This tracks the students' electrical appliances using electric count. Our system enforces a rule where a student can only bring a maximum of 3 items. This method simply checks if the count is less than or equal to 3. The rest of the class consists of standard setters and getters to allow other parts of our program to safely retrieve or update these booking details. Since the booking class is directly connected to the rooms and payments, let's move on to the room class to see how we manage the accommodation details. Next, let's move on to the room class. While the booking class handles student requests, the room class tracks the actual real-time status of each room in the hostel. For the attributes, we store basic details like room name and room type. We also keep track of 3 critical variables, current occupants, and a Boolean flag call is available. Inside the constructor, when a new room object is created, the system automatically initializes current occupants to 0 and set is available to true because the room is initially empty. To manage the room status, we implemented 2 important methods. First, check availability method. This method returns true only if the room is marked as available and the current occupants count is still strictly less than the max capacity. Second, update capacity method. This method automatically updates the room's availability if current occupants reaches or exceeds the maximum limit. Its available turns false, otherwise it remains true. Once a room is successfully verified and assigned, the system needs to finalize the booking by issuing a payment confirmation. For that, let's look at our final class, which is the receipt class. Finally, we have the receipt class. For the attribute, we use private variables to store receipt ID, payment status, and total amount, which uses a double data type for accurate pricing. Now, let's look at the key methods in this class. First, validate payment method. This method checks if the payment status is paid. It uses the equal ignore case function, so it will return true regardless of whether the user types it in uppercase or lowercase. Second, calculate total method. This method takes a booking object as a parameter. It calls the check electric limit method that we discussed earlier. If the student stays within the limit, the system calculates the charge by multiplying the electric count by 10 ringgit per item. However, if they exceed the limit, the system automatically caps the charge at a maximum of 3 items and prints a warning message. Third, print receipt method. This method simply outputs the structure receipt details, including the receipt ID, payment status, and total amount in RM directly to the console. Lastly, we have the standard gatherers and setters to safely manage these financial attributes. Now, I will pass the presentation to the next presenter to talk about the main program execution.
For our class application, we created two new objects, which is student and staff. We have in choice equal to 0 and we use do while loop in our main application. Here, students must choose between 5 options. Students must pick from these 5 options. Next, we use switch case in our main as it is more clear, simple and straightforward compared to if else, since we have to repeat several times. User must enter number 5 in order to exit the program. If they were to not press number 5, they are not able to exit the program.
So now we continue with our sample interface. So first, the sample interface shows student profile and status. This screen shows the student profile and status feature. First, the students enters their name and student ID. Then, by selecting option 1, the system displays the student's profile, including the student ID and approval status. In the example, the student's approval status is approved. And the besides of the student profile and status, it shows us create a new booking, which is this screen shows the create a new booking feature. The student selects option 2 and enters the booking details such as the booking ID, booking type, total number of students, and the number of electrical items. After all the information is entered, the system successfully processes the booking, generates a receipt ID, and displays the payment status and total amount. For the next one is check current booking. This screen shows the check current booking feature. The student selects option 3 to check their booking information. In this example, the system displays no booking found, which means the student has not made any booking yet. And besides check current booking, we have track room state, which is its staff. This screen shows the track room state feature for staff. Staff select option 4 to update and monitor the room status. The system displays the room number, maximum capacity, current occupants, and room availability. It also records which staff member updated the room information. For the last one, we have exit system. This screen shows the exit system feature. When the user selects option 5, the system ends the program and displays the message, "Thank you for using the facility booking system." This indicates the program has closed successfully.
For our conclusion, we have found, gathered and tested that our student hostel booking system reduces waiting time during registration day since students do not have to wait in line as they have already booked their rooms. Next, it is more efficient than the previous booking system as only one person has to do the booking. They only need to take their room key. Furthermore, students are able to book a room in the hostel according to their preference. Finally, it benefits both students and staff in room booking as the process runs smoothly.
Today, I will be presenting our Java project, which is the facility booking system. Let's start by running the system. Once the system launches, the user is required to enter their name and student ID. We will enter the name Farhana, and for the student ID is 2025 747357. Upon successful registration, the facility booking system main menu is displayed with 5 main options. First, let's verify the student profile by selecting option 1, which is view student profile and status. As you can see, the system successfully retrieved the name, ID, and the student approval status, which is approved. Next, we will test the core functionality, making a booking. We select option 2, and the system will prompt for the booking details. We enter the booking ID, which is 303402, room type BK1, and set the total number of students to 2. Following that, the system requests the name and ID for each student involved in this booking. We input the name is Aisha and her student ID. And for the last one is we input the electricity usage count. Once all details are filled in, the system displays the message booking created successfully. An official receipt then automatically generate contain the complete booking summary and the breakdown for the total amount, which come to 20. We can also monitor the current facility condition by selecting option 4, Track Room. The system displays the room details such as max capacity of 120 people, the current occupancy, and the room available status, which is currently available. Finally, to close our session, we select option 5, and the system displays a thank you message and terminates successfully.